Cannot hear me. I can speak loud. Okay. Yes. Thank you for. Okay. Okay. I just wanted to do it a bit more lively, but I have to sit down. I will sit down. Thank you for the invitation. It's great to be back in Geneva. I have been in this room and I have been in your school a couple of times now. And it's also a pleasure for me that this year I will be also teaching some of you in an effort of together trying to see and explore what comes next into the architecture and the urban scale. I especially want to thank Manuel Gausa and all the amazing Geneva team for the organization of this 3-day intensive brainstorming. And of course the whole team of the Knowledge Alliance for Advanced Urbanism, this European project that was an opportunity to bring us together and work on discussing and proposing on educational models, but also new proposals for the next step in the urban scale. So I will be talking today about responsive environments. Danielle, in the morning session, has been talking a lot about adaptations. I want to introduce the idea of responsiveness as a kind of a tool or a behavior that we can achieve through our design and through our proposal of systems and systemic approaches. So responsive environments are an outcome of all the technological tools that we have today and all the new means that they are influencing not only the way that we interrelate with our physical world, but basically the way that we design that physical world for us, that we are designing the spaces. So we're witnessing a radical design process that it is closely related with the fact that we are not talking anymore about pure form. It's not about forming out of our designs, but it's rather about performing. So we do speak about performance. We want to understand how our buildings are not just designed, but how they perform during time, how they interact, how they respond, how they adapt to environmental conditions, but also how they adapt and respond to the user's needs. So technology is becoming our tool to design those behaviors, and in a way I might say that we are passing from the machine for living in, that was the model of Le Corbusier in a representation of the machinic age, into a living machine that I consider it is a representation of the information age. Of course, all of us, we are very familiar with this kind of images that they are a kind of a representation of the ideas that we have back in the 60s or the 70s and the visions that we had. We were able to design and sketch ideas of cities that they can move, buildings that they can be like robots, things that they are not static anymore. No, we're very intrigued about that idea of how we can combine the physical space with technologies of motion or technologies of interaction. One of the main changes that we see today happening and we experience in our practice is the fact that we do have the technologies to mainly construct and build the majority of the things that we have been imagining back a few decades back. And this is a radical change in our discipline, and this is a radical change in the process of our operation. If we also start thinking on the accessibility of those technologies. A few years back, the first computer ever, it was basically that image on the screen. It had the size of a room, it was huge, and it was accessible by very, very few people that they have the knowledge of it. So if we think that the first computer were once the size of a building, what is happening now is that buildings are becoming computers. And they are becoming computers able to be programmed into a nanoscale, which means that they are being able to be designed from the very micro nanoscale, and of course they are being able to operate in input and output communication protocols. Therefore, they are not anymore static structures, but they are becoming living organisms able to be designed, but able also to control their own performance by evolving, by learning. If we also think that the Industrial Revolution was the one that brought the cities, the contemporary cities that we inhabit today, this is Barcelona, the Cerdà plan, the city that invented urbanism. But of course that urbanism, as in the most contemporary cities, it is based on one single element, which is the automobile, it is the car. No? And the urbanization that happens around that scenario is very limited, and it's only touching very few layers of the urban complexity. So if that is what the Industrial Revolution brought us, I am wondering what is the information and the digital revolution bringing to the cities. And the revolution that I see coming is the one related with connectivity. Connectivity in terms of information. We are now able to have access to information. Information has been democratized for everybody through the Internet 2.0, but also connectivity in terms of social interaction. We are able to interact with people far beyond any limits of physical proximity. And last but not least, especially for the ones that we are dealing with the physical space, is the connectivity in relation with merging the virtual and the physical data. So merging the virtual and the physical spaces. And of course, it's not new, the fact that in architecture we are trying to understand how advancements of computation or how advancements of technologies are influencing the physical space. Back in the 50s and 60s, a lot of pioneers of computation tried to mix those cybernetics advancements on understanding how the physical space would be influenced. Many of them, such as Nicolas Negroponte, the leading and the founder of the Media Lab at the MIT, but as well Gordon Pask or Alan Turing, that he was doing this very interesting experiment in order to debate that it's very difficult to understand and to detect the difference between a human mind and a computer mind. And the question that he was posing with his scientific research was, whereas the machines can think. So I think that as designers responding to those technological advancements today, we need to try to make the questions of whereas our buildings can think, or whereas our cities can think, and not only think but also evolve, which means learn out of patterns and have an intelligence embedded and integrated into their structure. Starting with the urban scale, we see that there is a big trend into the idea of the smart city, very nicely done in this symposium. There is a mix of that idea of intelligence with resilience, and I think it's very successful. But no doubt there is a trend around the smart city, and the trend is basically focused on corporation ideas, because in all this kind of thinking, the main goal was to sell and buy technologies, no? And of course that is not what we're interested about, but it's also true that the power of information and communication technologies are allowing us to see the urban design in a different way. So cities are dynamic ecosystems, but traditionally we have been designing based on very approximate data. Approximate data, for example, of population, approximate data of flow of people, approximate data of environmental conditions, and those data today, they are not approximate anymore, because we do have the technologies in order to collect them, capture them, and know the changes every second. So if we do have the technologies of capturing those real-time data, then as designers we do have the responsibility, and we should have the responsibility, to design in a more dynamic way. So starting by the analysis or the cartography, no? We are able to start creating more real-time and dynamic cartographies based on data related, for example, with occupational patterns. They are changing every day, or every time, or during the weekend, or during the weekday, but also how to overlap those kind of occupational data with time, with data of time, or with data of GPS geolocation and services, so that we can start to have conclusions out of this overlapping of information of how cities are being navigated, how they are occupied, and how we can design based on that behavior coming from the users of the space. Apart from cartography, we also need to start thinking how we materialize these ideas into spaces. So it's not only anymore about trying to create a space that is able to program, to host different programs over different times, but how we can start creating materialized ideas, physical spaces that they are able to adapt, to change their physical form so that they can allow different programs to be hosted on those spaces and on different timetables. One of the very important aspects of that dynamicity is becoming the fact of which are the controllers of that dynamic behavior, no? It is very important to understand that we are now talking about smart cities, but ourselves, we are also smart citizens, because we all have a smartphone, almost all of us. We have a smartphone, a very powerful microcomputer into our pockets, and this is allowing us to occupy, navigate, and interact with our cities and our physical environment, also with our peers in a different way. So we are using apps in order to optimize our distances. We are also using apps to start being aware of the data that ourselves were generating. So by using those technologies, users are becoming more integrated into the different aspects of the urban complexity. We are able to visualize our neighborhood data, we're able to participate in public space distribution, we're able to access different urban interfaces, and in a way calculate shortest routes or take decisions more informed about how we move and how we interact in our cities. And there are technologies appearing that they are new in terms of processes, but also in terms of perception. We have things like augmented reality and virtual reality, tools that they are allowing us to overlap those digital information, that digital data within the physical space. And that, as I said, it is changing the way that we're designing, but mainly it's changing the way that we perceive the space. So back in Barcelona, we're working on understanding how those tools are allowing us to, for example, first of all, try to see how the static objects on the city, they can give back to the citizens, and they can give back to the urban realm by offering information and by allowing the people to program the spaces that they are navigating. Also for the criticism that those technologies are not accessible to everybody, we have been working on last year on a project in Mumbai when we were called to make a proposal of designing a chawl. The chawls in Mumbai, in India, they are in between informal settlements and formal settlements. So they are something like slum, but not exactly in that condition. And we have been going to Mumbai not with final design aesthetical solutions, but we went there with open systems that allow us to communicate with those people, to give them some very cheap technology of augmented reality and allow them to experience how the space could be and what is the space that they wanted to have. No? So by having feedback through those technologies, we were able to inform our design and continue on our systems and our final proposals. Also, 1 month back, we have been participating in a project in Barcelona, the famous Superblock that I think Salvador Rueda will be describing this afternoon. So it is a project that is liberating a big amount of public space in the city. No? And of course, once you have such public space, such open space back to the city, then the question is, what do you do with that space? Or how do you design it? And who takes the decisions of designing it? So by a very simple installation that was more like a game rather than a design, we went there with a series of elements and we allowed people to move them around in an effort of understanding where did they want to have a sport infrastructure, where did they want to have an urban orchard, where did they want to have more greenery and less greenery, etc. And by using technologies of augmented reality, we were also able to give them and to understand the impact of that movement of the elements. So what does it mean to have more greenery in that space in terms of contamination? What does it mean to have a leisure infrastructure in terms of social interaction, or in terms of adding nodes into the existing infrastructures of the city? And that is becoming a tool for design, but it's also becoming a tool for allowing people to participate in that design processes. And of course, all those new technologies or all those new processes and tools, they're requiring a new infrastructure for the city, for our contemporary cities. Until now, architects and urbanists, we had a very specific vocabulary that it was not touching vocabulary related with the engineering, such as Wi-Fi or networks or gateways or fiber optics and all those technologies. They require to have this kind of new vocabulary, and they require us to start thinking of a new urban infrastructure. The city of Barcelona recognized the necessity and asked us a couple of years back to create some technical guides of how information and communication technologies can be applied into the public space, but also how systems of renewable energy can be applied into the public buildings. So it's a technical guide that every architect or urbanist that is supposed to do a project in the city needs to have as a kind of a guide, an infrastructural guide. Allow me to also change scales, because it changed scale a bit, because when we're talking about responsive environments and when we're talking about a more dynamic city, it's not only the urban infrastructure that we're talking about, it's also, of course, our buildings, no? And we're working on understanding how we can start programming our buildings, no? Planning and landing is the session of this afternoon, but maybe I would say that it can also be hacked some way, and we can also say that it is programming or even planting and collecting and harvesting. So we're working with understanding how new materialities, smart materials, materials that they are able to change their properties in combination with Internet of Things and artificial intelligence can allow us to start creating more passive and more dynamic systems for efficient buildings. For example, our structure has been traditionally thought as something that it should be rigid and stay there forever. If materials in the architectural construction were eroded or they were changing, that was a very negative part for our discipline. Now we are also starting to debate and question that durability by trying to work with, for example, materials such as said memory alloys, which are the ones that you are seeing on the screen, which are basically nitinol wires that when they are heated, they are able to change their length, for instance, in a very passive way, just by changing the outdoor temperature. So if we start integrating those changes of the dynamic materials and the materials themselves into our designs, then we have new processes of designing more dynamic structures that they are able to grow, they're able to shrink, they're able to expand, and they're able to interact into the environment, but also into the user's needs. Users' needs are something very fundamental. We always need to find the balance if we're talking about optimization, energy efficiency. You very well in your introduction was talking about those challenges. But of course, how people can also have a say on how the structures or their buildings could be is becoming very important. So we are also designing not only smart material systems, but also interfaces that could allow users to interact with those dynamic systems and allow them to change their space according to their needs. Continuing as well with my slide, it doesn't change, but it doesn't matter. I also wanted to refer to the fact that smart materials or dynamic materials are not only the ones that they are embedded with high technological systems, no? We're also working with understanding how biomaterials can also allow us to create passive systems for heating and cooling, or as I was saying before, growing systems, how we can grow our materials, how we can start thinking that our buildings can grow, not just being static as from the very first moment of their construction. So we're working, for example, with with moss or alga, with the property of the plants to have the photosynthesis, and we are trying to capture those ions that they are being generated on their roots by creating anodes and cathodes, which allow us to generate energy. So how can we start thinking that we can have biophotovoltaic panels into north orientations or into humid and dark climates that they are able to generate the energy that we need to consume? Well, the answer is obviously yes. We might need to produce more surfaces of square meters, but the technology is very low in terms of sophistication, and the cost as well is very low in terms of production. Finally, one of the interesting things for us is to pass from the digital interfaces to the physical interfaces. We don't want to always have a screen as a mediator in order to interact with our environment, but we want that all those technologies are embedded into the nano scale of the buildings themselves. So we're also working with materials such as graphene. This is actually a research done in collaboration with some great guys here in Genova, with the Italian Institute of Technology and the Smart Materials group, and we have been working on understanding how graphene, which is an extraordinary material, new material, invented a few years back, that it's a material that is able to absorb energy, to generate energy. It is able to transmit heat, transmit energy, and transmit information, and it is a very thin layer of monoatomic carbon lattice, which means that it is also a material that it is a supercapacitor and a superconductor. So if we start applying those kind of materials into our building surfaces or structures, then the buildings themselves, the surfaces that surrounding us, are becoming interfaces for people to communicate and interact with them, but also to speak among them, no objects that they are speaking among them, or buildings that they are communicating among them. Of course, in order to many times to produce many of the things that we are researching, we always need to create new tools, because the existing tools are not the ones that they allow us to achieve that. And I am referring into that because it is part of what we're doing back in Barcelona, and it's also part of our educational methodology, is to learn out of making and to teach our students how they can create their tools in order to propose and apply innovative ideas. So I will be very quickly showing some projects that we have been working on digital manufacturing, especially on 3D printing in construction. 3D printing is a new technique in digital fabrication. Well, it's not that new, but it's becoming very expanded and spread today in different disciplines, and we have been working on understanding whereas this technique can be applied into the construction sector and architectural scale. So we have been trying to first see how, by combining different materials such as thermoset polymers, we can start controlling in a way the curing time of the material, and by depositing layer by layer those materials, we can start constructing in 3 dimensions rather than constructing and assembling in the traditional way of 2-dimensional processes and putting together pieces on sites. So how can we start thinking that we can go on sites where there is no infrastructure, we can use the materials that we can find on site, and then we can start creating structures out of scratch. This is, for example, some of those projects that we are working with printing clay, so working with earth. Earth is something that in vernacular architecture we have been working for. It's not a new technique, it's a traditional technique and material, but we're trying to see how we can hack those processes so that we can have much more complex forms, and of course, as I was saying, more sustainable processes that they require no transportation of the material, they require no transportation of prefabricated pieces and assembly on site. And of course, some of those limitations of those projects that you see here, and a criticism that I also do into that project, it's related with the fact of the scale. In order to be able to print big, you always need to have a big machine. And that is not sustainable at all. So it's not very aligned with the ideas of sustainability. And based on that idea, we started to explore with our students, researchers, that they are basically architects, but still they are entering into understanding how they can build their own tools. So we have been working on developing not so much design processes, but mainly construction and fabrication processes. So we have created a series, a family of 3 robots that they are able to go on site and collaborate among themselves in order to print something bigger than themselves. I don't know if you can hear the sound. In any case, the sound is not very good, but here you can see an experiment that we did back in the Design Museum of Barcelona. This is the first robot that it goes on site and it creates the foundation base. Then the second robot comes and grabs into that foundation part in order to continue printing. And the third robot that you will see in a while, it is able to print vertically. So printing vertically, or the combination of horizontal and vertical layers, allow us to create complex forms that we were not able to create until now in one shot. My video is a bit, I don't know why, slow. That is the second robot, and I will move it, try to move it forward in order to see the third robot. Okay, I know my time is a bit off, so I just want to sum up by 2 projects that they are based on the idea of how we can create some of those ideas into real scale prototypes. Now, many of the projects that I have been seeing might seem futuristic or might seem very far away from reality. Some of them they are, but some others are not that far away. So as architects, we're interested to go into constructing and understanding the limitations of the real scale and the sites. And I will show you this project that it is an old project back in 2010 when we were selected to participate in a competition of called Solar Decathlon. So it's a competition where 20 schools from all over the world were selected in order to produce a solar prototype. So we started brainstorming on what is the prototype that we would like to showcase there. And then we decided to not design something final, but create a parametric model that would give us the most optimum form in order to capture the maximum of solar energy during, based on the site that it was to be implemented. So here you can see a table of different forms of that house, if it was to be implemented in Madrid, which was the case, or in Reykjavik, or in Nairobi, or in Ecuador, where the solar movement is much more planar. Therefore, you probably don't need such curvature in order to capture energy. So that was one of our first efforts, and the second one was to fabricate it almost completely in our infrastructure, in our laboratory back at IAAC in Barcelona, because we want also to explain that sustainability, it's not only in the performance, but it's also in the construction process. So if similar laboratories existed in other parts of the world, then the only thing that we need to do is to send data with the speed of internet, download data and fabricate on site. Therefore, physical objects are becoming basically numbers, values and data that they can run with very quick speeds, and they can allow us to avoid monetary or energetical costs related with transportation, which is a bit the industrial model that we are experiencing in the last 200 years. No? We are producing very far away from where we're consuming. And those are some of the images of the assembly and the final image of the house that was able to generate twice as much the energy that it needed. Of course, that was in July in Madrid. That was very, very hot, and it was an easy task to do. But if the infrastructure of the city, and that gets me a bit back on what I was saying before, was able to accept those kind of structures, then we could give back to the grid during summer, and the grid could give back to us during winter that we might not be able to generate as much as we needed. I will finish up with this second prototype, that it is very much aligned with the idea of solar house again, but although the previous one was an understanding of a form out of scratch, this is an understanding of a system of how we can create a facade system, a skin system that could be applied into existing buildings as well, and not only buildings out of scratch. So out of solar analysis, we had the most optimized inclinations into the facade, and that was a bit the final object we developed in Barcelona. So just a few keywords that I think they are important when we're talking of what is coming next into our design processes, and what is coming next also into the educational processes related with design, is the fact that we need to start amplifying our knowledge and our vocabulary. We need to start to learn how to program, to understand ideas of open source, of building our own tools, of learning out of making, of creating distributed designs, and also of learning from each other and being able to interact on that. That is a bit what we're trying to do in Barcelona, and I would just like to thank you by sharing with you the fact that we are moving towards a different forms of habitat where architecture should not, and it's not merely inhabited, but it's becoming technologically integrated. It's becoming interactive but also evolutional. And facing that change, I also think that we need to understand our responsibility as designers and our responsibilities as users of the space, that we cannot keep on continuing designing with the same way, and we cannot keep on inhabiting our spaces with the way that we have been doing so far. So thank you very much.
Yeah. Thanks a lot, Areti, for the very fascinating experiences that you explain us. I would like to ask to come here Pierre-Alain Travelot for his presentation.